encounter small air resistance to its motion, then is asking what will happen on. Okay, this is the Earth. There's a very good problem. You should not analyze logically with your basic concepts. Huh? You should not just manipulate things here, at least such problems. So there's the orbit. Okay, we'll put it circle. It was supposed to revolve in circular orbit. So this is the initial circular orbit. This is the orbit. So what is the speed? Let's assume that orbital speed, erroneous, write it, R naught. It is having a speed V naught. It will encounter a resistance. A resistance will come. What will happen to the path? The path is going to be spiral. A perfect, I think, shape may not come. How many rounds? It all depends upon the resistance offered by it. How many rounds it will make it? This one. This called like a spiral it is. So it will be of this thing. Now he's asking about all the things now. So this is without a resistance. Path. Okay, let's directly get into the discussion now. How to analyze this problem? Shall we make a guess of things, or shall we really bring some mathematical proof? What is air resistance? Viscous drag, no? Air resistance nothing but viscous drag. A viscous drag will be there. They'll be acting on the satellite at all the positions. Now, because of that, air drag is there. So what should happen to the total mechanical energy of system? I'll ask you some very beautiful questions here. What is R? Let me take a certain instant of time. It will be a distance R, radial distance R, and it will have here the velocity V. Overall, the energy of satellite, what is the basic equation? E equal to minus gm mass of the Earth, m into 2r, we'll write it like this. There's a total energy of satellite. So now we know that small r will keep on decrease. No, initially it was r naught and finally become capital R. So what's happening to radius of that particular path is decreasing. If radius decreases, what should happen to total mechanical energy? So we should discuss both things, no? Interaction potential and also the kinetic energy. So basically, what is kinetic energy? How you write kinetic energy? Mod of E. No, we know that R decreases. As R decreases, K increases. Okay, this. And what about the potential energy? If and look at this equation. According to this equation, is since negative sign is there, if R decreases, E will decrease. If R decreases, K increases, and E what happen will decreases. The reason for this is like because of viscous drag. Then if E decreases means what should happen? Therefore, potential energy must decrease here. If I go and check it now, the rate at which potential energy decreases will be greater than the rate at which kinetic energy increases. The rate at which kinetic energy increases. So kinetic energy increases justified. Overall mechanical energy decreases, but the decrease in potential energy the rate at which potential energy decreases, no, that will be greater than the increase in kinetic energy. So therefore, the overall energy of the satellite decreases. Where it will go? Converting to heat. It utilized to overcome that one. So kinetic energy increases, I'll justify. This will not come. What about the angular momentum? So what is the angular momentum of satellite? What is the basic formula? Angular momentum should be equal to mvr. Let me write about O. And what is the orbital speed? Gm by r. So this I'll send inside. Look at R. R decreases. So what should happen to LO? Decreases. So its angular momentum above the Earth decreases. So these two are justified. Now, this is taken on. No, its period of revolution around the Earth increases. What about this? Period of revolution. The period of revolution depends on what? The time period of revolution. Well, it depends on small r. That is what you have to check it. So what is the time period? 2 pi r by v naught. V naught is what? And the time period is, or Kepler's law, proportional to t square proportional to r cube. Now, period of revolution, if like as r decreases, t should decrease here. If telling increases, so this is ruled out. But sir, how you can say time period? Let's assume that I know it's not a exact circular motion, but let me take this as a reference line. So now it will start like this. Again, no. So this particular thing you can call it as a still time period only. It may not be exact periodic motion, still time taken to go round. So that will keep on decrease. So what is the time taken to go around like this? Means here like this. This time you take it. Then time taken this one. So it keeps on decreases here. What time it takes to go around like this. Then again it will take time. No? So call this as T1. Call this as T2. So definitely T2 will be less than T1. That's what he mean to say here. So these are some conceptual way of testing students. You should go there. So where do the decrease in mechanical energy will go? Convert into, is used to overcome the viscous drag. The decrease in is converted into heat, or is used to overcome the viscous drag. I need tomorrow 1 hour because paper discussion, I don't know, some timing problems will occur and will end up because some good questions are there still. Some very good multiple ideas that we can discuss only in the end of the chapter, not beginning of chapter. So tomorrow I need 1 hour. So you tell to Venkana sir to adjust his timings properly. I think evening 4 to 6 will be free, no? It seems. Am I right? Anybody reply back? 2 to 4 math class will take place, no? 4 to 6 nobody. So why don't you ask the chemistry sir to take 4 to 6, no? So that 6 to 8 will get a time. So you just request chemistry sir, Venkana sir to engage 4 to 6 so that we can have our slot 6 to 8. I'll also inform him. Okay, tomorrow we'll continue few more discussions, just only for our understanding, learning purpose. Like some pathfinder problems we did know, nobody will ask you in exams, that one only for learning, because multiple ideas are there. No, mains nobody will ask you. For advances they may ask you. For mains, okay, all that may not be needed. Okay, tomorrow we'll continue. After paper discussion we'll discuss